Hello, my name is John Weeks. I'm an engineer here in the Constellation Ground Ops office at KSC. I'd like to discuss a risk that we've been working for a couple years now related to Orion surface contamination during our assembly operations in the vehicle assembly building. The issue first gained visibility when the Orion project provided us with the requirements for cleanliness following spacecraft turnover to the government for processing. The specific requirements that caused us concern were external crew module cleanliness levels that were visually clean standard, or VC standard as they say. And this was for surfaces that during our assembly ops are going to be exposed for at least a couple shifts in the VAB. Now, the VAB being a relatively dirty environment with airborne particulate, this caused us some concern, and all the experts that we consulted with on this issue agreed that a couple shifts of exposure time of these surfaces in the VAB really was not workable if we were trying to maintain them at the VC standard. So we performed a study. We looked at incorporating a full-up clean room up at the 300-foot spacecraft level in the VAB to mitigate this issue. And this clean room, this included the positive pressure purge system that you would need for something like that. This included internal lifting capability that would allow us to pick up the ogive fairing, move it over, and set it on the spacecraft. All that capability for a clean room at that level had a life cycle cost estimate of on the order of $20 million. So as a result of the high estimate for implementing a full-up clean room in the VAB, the Orion project took an action to look at possibly mitigating this issue with spacecraft covers. The idea here was to come up with kind of a segmented cover that you would only remove the portions of the cover you absolutely had to for the particular assembly ops you were working. With this approach, you'd probably only be exposing, say, a couple percent of the total surface area at a time. Easier to keep that area clean, maybe even clean as you go if you need to. But the idea was that segmented covers could also mitigate this issue, in lieu of a clean room. Problem was, life cycle costs for that option came in at around $5 million, so we needed to look for another alternative yet. About the time we were working the segmented cover development with the Orion project, it was brought to our attention that they were in the process of demonstrating an open-top modular clean work area in the operations and checkout building, O&C, high bay. This is the area that ultimately Orion is planning to do their primary assembly operations of the spacecraft. And their concept for this modular clean room was to use it in the areas that they wanted to get a little cleaner than the already 100,000 particles per cubic foot that the O&C tends to be, just nominally. So we looked at this and said, well, if this can clean up the O&C in a localized area for ops, why couldn't we maybe implement this in the VAB? Now, in the O&C, they were trying to get from about 100,000 particles per cubic foot down to about a 10K. I'll just say 10K for shorthand notation. And the demonstration tests they did, they were able to achieve those levels, maybe even a little better. Our objective in the VAB with that same hardware would be, let's see if we can't clean up something that's probably 3 megaparticles per cubic foot down to maybe 300K or something like that, which most of the experts we consulted with felt that's the particle count that we'd need to get to for a couple shifts of exposure. The way this modular clean room works is it's an open top area that's got a HEPA filter supply wall with blowers and HEPA filters in it that take the air from the outside ambient, filter it, and blow it across at about 1.5 feet per second airflow rate, which should remain nearly laminar for the conditions we've got. And then it's pulled out by a discharge wall, no filters, but just blowers on the discharge wall that pull that out and exhaust it. The concept here is that as particulate is settling from above, that particulate will get carried by that airstream prior to settling on these sensitive surfaces. So it really is, this particular concept really is well suited for what we need, because we need something with an open top so we can use the facility crane for lifting and yet we need something that can keep us clean and keep these surfaces clean during assembly ops. So our ground systems group, they went off and did a study to investigate what it would take to implement this open top modular concept in the VAB to mitigate this issue. The initial results from that study are very promising. However, we don't have a final life cycle cost estimate as of yet. We would like to demonstrate this open top modular clean room in the VAB, specifically in High Bay 4 on the ground floor. We would like to demonstrate its operation and effectiveness. Even though we're going to implement this concept up at about 300 feet around the spacecraft, we're using the ground floor demo partly just because it's much easier to set up there, and also we think it represents a credible worst case. Particulate environment at the ground floor should be, in most cases, worse than what we'll see up at the 300-foot level. We're hoping to see an improvement from around 3 megaparticles per cubic foot down to around 300 K. And if we can get that type of improvement in the environment, we feel a lot better about implementing simple covers for Orion, and we also feel a lot better about potential contingency operations that might require us to have surface exposure times greater than the 2 shifts that we have nominal. Well, at this point, because of the uncertainties associated with the Constellation program, we have put the demonstration test in the VAB on hold. However, we do believe that regardless of what our path forward is and whatever spacecraft may wind up being assembled in the VAB, that we're going to need to demonstrate this capability eventually, because most likely our forward plan is going to need some sort of mitigation in this regard. Well, in summary, as we've worked this issue, we've kind of converged to more cost-effective solutions. I mean, initially when we were first confronted with the challenge of these cleanliness requirements, we looked at the full-up clean room up at the 300-foot spacecraft level. Of course, the life cycle cost on that approach was prohibitively expensive. So we looked at the spacecraft, perhaps, designing segmented covers, much more elaborate cover techniques that we felt would have mitigated this issue. But again, the life cycle cost was way up there, and we continue to look for other options. It looks like the final point we've converged on here is that this open-top modular laminar flow clean room probably will mitigate this issue, and we certainly hope to still demonstrate this capability at some point in the future. But I would say that regardless of what direction we take as a program or as an agency for manned spaceflight, if we're assembling spacecraft in the VAB, we are going to need some form of particle mitigation, and this open-top clean room looks very promising, like it is the future. If you'd like more information on this topic, you can contact John Weeks in the Constellation Ground Ops office at KSC, and my phone number and email are in the global.